Lesson 1, proportional relationships. So you've talked about proportions before, and they're pretty important because they are the basis of all linear functions. We're going to spend obviously a great deal of time with linear functions this year. So let's sort of talk about some things that are particular to this. So when we talk about that proportional relationship, two variables have a proportional relationship if their respective values are always in the same ratio. So same ratio, that kind of brings to mind constant in my mind. They have the same relative size to one another. In the equation, if the two variables x and y, then y divided by x equals a constant. So y divided by x equals some constant. This should kind of ring a bell to you. Something being constant, we're talking about a linear relationship. We did spend a fair amount of time with the average rate of change in the last unit. So this obviously is your rate, okay? Or in other words, your slope, okay? Your average rate of change, it's your slope. And it's constant because it's linear. So it says, at a local farm stand, 6 apples can be bought for $4. Determine how much it would cost to buy the following amount. And then we got to round to the nearest cent. So if I know that my cost $4 per 6 apples, okay, $4 for 6 apples, that's my constant. I know that. So now they're asking, okay, so then what's a dozen apples? So mathematically, what's happening? We've got dollars to apples is equal to dollars to a dozen apples. And then we could cross multiply pretty simply there. 6x equals, 48. And x is equal to 8. 8 what? $8. Okay? So then the same thing with 20 apples. We have our constant here, that rate, $4 for 6 apples. So I can figure out how much 20 apples cost. And when I cross multiply, 6x equals 80. And doing that division to the nearest cent, $13.33 for 20 apples. So now they're going to take it and they're asking us, okay, so it says if C is the total cost of apples and N is the number of apples, write a proportional relationship between C and N. We were just using that up there. We were just using X's. Solve this for C. So again, I start out with my cost for 6 apples is equal to my cost for however many apples. And then if they're asking us to solve that for C, again, we cross multiply. So we'd say 6C equals 4N, and they ask us to solve for C. So I get C is equal to 4, 6 times the number of apples. That 4, 6, there it is. There's our slope, okay, or our rate of change. If you really wanted to, you could simplify that, and that an equivalent would be 2/3 N. So the cost is 2/3 times the number of apples. So $2 for every 3 apples, $4 for every 6 apples. You get the idea. So we've got that constant rate of change. Now they're asking us to graph it. So down here we have the number of apples N and we have the cost C. So if I buy 0 apples, I'm not spending any money. But my rate, and I'm going to use the 2/3 just because I simplified it. So my rise 2 and my run 1, 2, 3. Up to run 1, 2, 3. There's my slope. There's my rate. There and how much it costs per. In this case, every 3 apples costs $2. Up to run 3. Up to 1, 2, 3. Sorry, my eyes aren't as good. Did I miss one? Up to 1, 2, 3. I did. All right, I'm going to pause it and fix my mistake. All right, fixed my mistake. Sorry, my old eyes skipped over some things. All right, so I'm going to connect that, okay, with a nice straight edge there. And Now, it says according to the graph, C of 15 equals 10. So C of 15, remember, that is our N, or our number of apples. 15 equals 10. That's that point right there. Illustrate this on the graph I just did. Interpret, how do you interpret C of 15? Meaning, what does it mean in terms of apples and money spent in the context of the problem? So that is 15 apples, okay, cost $10. Okay. All right, when you go ahead and flip the page, you guys are going to do all of these through the bottom and come to class with those done. All right, so let's hop over to the next lesson. So go ahead, bypass the homework, and let's look at lesson 2, unit conversions. Okay, these could be fun or they could be totally painful. It just depends. So we're going to do a few of these, and then I'm going to have you do a couple for class. Okay, we're not going to do all of them on here though. Okay, so it says John has traveled a total of 4.5 miles. There are 5,280 feet in each mile. How many feet did John travel? Set up and solve a proportion for this problem. Okay. Also, do the problem by multiplying by a ratio. So if I were to say, I have to think to myself, I'm thinking about, I'm going from miles to feet, because that's what the question is asking me to do. So my proportion would be 5280, that's my feet, is in 1 mile. I'm going to put in those units. This is my proportion because it's asking me to do this 2 ways. So therefore, how many feet in 4.5 miles? And then I would do that cross multiplying, and I end up with 23,760 feet. Okay? So it says also do the problem by multiplying by a ratio. So I'm thinking, okay, 4.5 miles times 5,280 feet per 1 mile. That's exactly what's happening here, and that's exactly what we did in this. So when we think about our units, our miles would cancel. That's what we want, because we want to end up with just feet in our answer. Look back to what I did in the beginning. I said we're going from miles to feet. So I need to get rid of the miles. So now I'm just multiplying 2 fractions here. So 4.5 times 5280. Again, that gets me to my same answer of 23,760 feet. Okay. So obviously very simplistic there on that one. So let's take a look at number 2. So it says, if there are exactly 2.54 centimeters in each inch, how many centimeters are in 1 foot? So the problem wants us to go from feet to centimeters. Okay. So I'm going to start out with what I need to go to. Okay, that 1 foot. And what do I know about 1 foot? Think about some background knowledge. And what else do I need? And keep that in the back of your mind and kind of mull that over for a second. And then what else did the problem give us? It gave us that there were 2.54 centimeters in 1 inch. All right, so I've got feet, I've got centimeters, I've got inches. I need something to tie those 2 together in the middle here. So background knowledge, inches in feet. What do you know about how many inches are in a foot? How many inches are in a foot? Hopefully you're saying 12. So now we have 12 inches in 1 foot. So let's just take a look at the units, okay? So if they're on a diagonal from each other, we can cancel them out. feet, and feet. Those canceled out. Inches in inches. Those canceled out. What is the only unit that I'm left with? Centimeters. Is that what the problem asked us to do? It certainly did. It asked us to get to just centimeters. So now, just got a multiplication problem. So I'm multiplying three fractions. What's 1 times 12 times 2.54, and you should come up with 30.4. And what are we talking about? Centimeters. Okay. Hop down. One more to go. We're gonna hop down to number 4. You're not gonna do number 3. Okay. Hop down and let's look at number 4. Number 4 could get a little crazy, but I think we can do it. Okay, it says the mile and the kilometer are relatively close in size. Can you convert 1 mile into equivalent kilometers? Okay, here's what I'll give you. There are 2.54 centimeters in an inch. We just talked about that in the last problem. 5,280 feet in a mile. We talked about that too. 100 centimeters in a meter. You should have that as background knowledge. 1,000 meters in a kilometer. Again, some background knowledge. All else you should be able to do for yourself. Round your answer to the nearest tenth of a kilometer. Okay? This takes a big string of multiplication, but I know we can do it. All right, are we ready? So let's think about what are we starting with and what do we need to go to? Okay? We need to start with miles and we need to get to kilometers. Okay? So let's start with that. 1 mile. So what do we know about 1 mile? We know that there are 5,280 feet in 1 mile. Okay? And what else do we know? I also know that there are 12 inches in 1 foot. Always put in those units because that's what's going to help us. Okay, I should put that 1 there. Times, we know that there are 2.54 centimeters in 1 inch. You should start to see patterns happening here. Miles and miles, feet and feet, inches and inches. There is one, for every 1 meter, there are 100 centimeters. Centimeters to centimeters. Where am I going to go now? 1 kilometer is 1,000 meters. So you might be wondering, well, how did I know to set that up that way? Look at the pattern that just happened. Miles and miles. Oh, feet and feet. Inches, inches. Centimeters, centimeters. Miles, miles. Boom! What am I left with? Kilometers. That's what I needed to get to. I needed to go from miles to kilometers. Now it's just a big, huge multiplication problem. So, on the top in the numerators, 1 times 5,280 times 12 times 2.54 times 1 times 1 in your calculator. I don't know what that gives you, but then we have to decide, we've got to multiply the bottom. 1 times 1 times 1, so far so good, times 1 times, 100 times 1,000. So whatever we got on the top divided by whatever we get on the bottom, you should end up with 1.6 kilometers. So for 1 mile, it's equivalent to 1.6 kilometers. All right, you guys are going to go to the next page. Go to the next page, and I just want you to do number 5. All right, see you guys in class.